You're seeing my PowerPoint?
Yes, looks good.
Okay, good, great. Okay, so thank you for having me today. I'll be talking about AquaQAPP and MassWateR, two open source data tools that we've developed for water quality monitoring groups. So here in Massachusetts, there are dozens of community and watershed-based water quality monitoring programs, as indicated by all those colorful dots on the map. Those are all stations monitored by NGO organizations as of 2016. So you can see the coverage is incredible and more than we could ever ask for from state agencies and federal agencies. So given that, we really rely on these NGO programs for data in our required reporting to EPA. So as a national estuary program, we're required to report on environmental conditions in our estuaries and our watersheds. And the only way we can do that is with these data. So given that, we support and benefit from water quality programs that are collecting quality assured data. And it's in our best interest to build that technical capacity and offer technical assistance wherever we can. So we do exactly that at several different stages in the data life cycle, all the way from planning to reporting. To assist with planning, we developed AquaQAPP. And to assist with data review, archive, and analysis, we developed MassWateR. And then for reporting, we created EcoHealth tracking tool, which I don't have time to talk about today, but hopefully you could check it out. It's a web-based data viewer. So I'll be talking about AquaQAPP and MassWateR today and how those sort of assist in this data life cycle. Over the years, we've heard feedback from those many watershed groups in our region that QAPP development and data analysis are two major hurdles for them. And there was a desire for greater standardization and more tools to help them with these particular steps. So that was really the impetus, both our need for their data and their request for more tools and support. So a review of AquaQAPP. This is intended for freshwater rivers and streams, estuaries, and marine water quality and benthic sampling programs. It is a web-based wizard that guides users through a variety of forms to input data that come together to form a Word document, QAPP. That's a quality assurance project plan. And that generated QAPP, as long as it hasn't been significantly altered by the user, is considered pre-approved by MassDEP. So that burden of communicating back and forth and all the iterations that traditionally go with QAPP approval have all been eliminated through this pre-approval. It's also considered a QAPP built through AquaQAPP is considered acceptable for approval by EPA. So it was developed in close collaboration with both of those entities. And we have a lot of additional resources that go along with it, including a detailed user guide, on-call help. That's something that I do for folks. And we have about 30 different data sheets, templates for folks to use as part of their program, and lots of other goodies for resources. So I'm going to leave the PowerPoint and do a quick demo. I'm hoping you're still seeing my screen. Are you seeing a web browser AquaQAPP screen? Okay, good, thank you. So when you first land on the AquaQAPP page, which is aquaqapp.com, there is a login prompt. If you don't have an account, you would register up here. This is only used to connect your QAPPs with you so that no one else can access them. Your login information is not used for any other purpose. So it's just to keep your data yours, or your QAPPs yours. But I'm going to log in. When I log in, you'll see some items turned on at the top. You can now have access to a quick start guide, a very detailed user guide, and your dashboard. Your dashboard would be empty the first time you launch it. And if you want to start a brand new QAPP, you would add it there. I'll just call this one test. You would give it an actual name. And when you start a QAPP, you see on the left-hand side, these are all of the different forms that you'll be guided through before your QAPP is complete. So you land on this getting started page with lots of tips about, how to begin, what sort of information to have in front of you before you get started. You can mark that you've done that, and you get this gratifying little green check mark to show you that you've done something. And you sort of just move on through each page, each form. Some are much easier and more straightforward than others. You can assign all of the personnel working on your project, giving them specific roles, data manager, lab manager, things like that. One really interesting menu in AquaQAPP is this water quality concerns one, where a program, especially a new program, might not be sure what parameters would best address the concerns in their water body. They might know that their stakeholders care about HABs. They're concerned about HABs and concerned about the effect on recreation. So a program might pick those two, and they could say if their concerns differ by sampling location. So some sites have HABs, some they don't think. So maybe yes, your concerns differ by location. Because I've selected these later in the menu, AquaQAPP will suggest certain parameters over others. AquaQAPP will integrate your selections here later on so that you're not overwhelmed by the hundreds of parameters that we could be looking at in water quality sampling. So you work through these different pages. The monitoring locations one is a nice one. You can do it two different ways. You can enter your locations via map. You could drop a location this way, drop it, and then fill in all the information about that site. Or you can add it in sort of list format where you're adding it, one at a time if you already have the site information. So I'm actually going to jump back to a QAPP that I've already developed just to show you what it looks like when it's a little further along. This is just a fake water body, or I imagine there's a crooked river somewhere, but it's just made up for this. So you'll see that some of the pages get into more of a narrative, open-ended type of form. If you're unsure about the level of detail or the format that is appropriate for a QAPP, there are examples for each of these. So this is, typically what agencies want to see when you're describing the project background or previous scientific efforts. I have filled these all in all caps so that when I show you the generated QAPP later, you'll be able to tell my inputs versus AquaQAPP's inputs. So just to make note of that. So after you've done all of the pages of AquaQAPP, you'll see that you have 100% project progress, which means you're ready to generate your QAPP. You click that and it takes, a couple seconds for it to download a Word document. Pull that up. This is what the output looks like. It's 69 pages long, and it comes with a cover page of including a checklist. Make sure you do these things before your QAPP is considered complete. It'll tell you certain tables that you might need to double check to look at and manually fill in a couple pieces of information. And we'll tell you which data sheets and labels and things like that you may wish to download from a provided Excel document. So for example, if you're a freshwater benthic program, anywhere you see an X there, you're going to want to take those data sheets and put them in your appendix of your QAPP. So then we get into the actual QAPP. This probably looks more familiar to what people are used to. QAPP cover page, signature pages. These are all very common. Table of contents. These sections are based off of EPA's QAPP guidance. So everything that EPA has requested in their guiding materials is represented here. So they're satisfied in that regard. And these are typical QAPP sections. So project management elements, this is the who and the what and the where of the program, and the data quality objectives. And then you get into the actual data collection components, how you'll sample, the methods you'll use, and how you'll analyze those samples, how you maintain and calibrate your equipment, things like that, both for fresh and marine water. And then sections for assessment and oversight. What do you do if there's some sort of error? What sort of corrective actions will you take? and data review and usability. So how do you actually calculate how your program's doing? And that's all detailed here. So we're obviously not going to go through all 69 pages of this, but I just wanted to highlight a few of the sections that I thought were very helpful. Let's see, I'll jump down to page. I hope I don't make anybody sort of seasick here. And just a note again about those all caps. So where you see the all caps, that's information I put in to the tool. So a lot of this is all user input, our sites and our program schedule across the calendar year. Data quality objectives has a combination of user input information and boilerplate information, standard for a quality assurance project plan. This is a very useful component of AquaQAPP. This is a table of the data quality indicators and acceptance criteria for each of your parameters. So all of the parameters that I picked from that pick list are shown here across these 2 pages. So there's a lot of them. AquaQAPP pulls, to create this table, pulls from a table that's operating in the background, all of these data quality indicators and criteria. This would take a program days or weeks to track down all of this information and, you know, go back and forth with DEP and make sure it's the right data quality indicator. This is a lot of time saved by it all coming together in this table for folks. And this table is really dealing with the units of measure, the accuracy of your quality control sampling, precision of instruments and things like that. Let's see, page 20. So then we're getting into lots of boilerplate language, so not all caps, as you can see. Standard, you know, these are really best practices with training requirements, document management. Here we see some all caps again. So this is a lot of user input data. I'm going to jump ahead a few pages. Oh, so here's an example where the user will have to go back. The cover sheet tells you where you need to go and address certain things. This is one of them. So this isn't captured in the tool. This is captured outside of the tool where the user has to say how often they're going to do precision checks for each sampling event. You know, so for conductivity, at 3 stations, you're going every week. Well, how many of those stations will receive a precision check? So you're going to do a field duplicate or a field blank or so on. So that's filled in this summary table here. But this is another useful one I wanted to point to is best practices with field quality control when using sensors. So all of the sensor parameters that I selected are shown here, and the best practices with field quality control. So you're making sure certain calibration steps have been taken and certain corrective actions if those pieces of equipment seem out of calibration. So that's done for each of the parameters. Include here we have nutrients, you know, best practices with sample storage, container preparation, same for water chemistry and fecal indicators. It's a lot of just useful information compiled into one place. Some details on instrument calibration procedures. So I'm sure you get the point here where it's pulling together these best practices so folks don't have to try to chase them down themselves. And then the last thing in the QAPP I wanted to point out, and it is very long, so we won't labor over the pages too much, are some of the boilerplate language about verification and validation of data. Folks, at least in our region up here, have expressed a lot of difficulty with this step, not knowing quite what to do and how to respond when they find that their targets aren't being met. So that's really laid out here. And you see this is all boilerplate, including how to actually calculate your accuracy and your precision, you know, if you're meeting those targets or not. So that's all there, and then we get into the attachments. So what I said earlier is that folks can consider their QAPP pre-approved if they don't make substantive changes to it. So they really couldn't go in and, you know, be deleting large chunks of these best practices and still assuming it's pre-approved. That's not the case, but minor changes, and those discrepancies are detailed in the user guide. You know, it's described there what's a minor change, what's a major change. But as long as folks create the QAPP, fully read and understand what they're agreeing to, agree with the protocols that are there, then they're considered pre-approved. So can AquaQAPP be used in other states? Absolutely, yes. While it was developed with significant input from those agents from MassDEP and EPA, there's really nothing that's specific to Massachusetts in it. It's really just that Massachusetts DEP ensured that all of their preferred analytical methods and data quality criteria were in there. Those are often very common, if not identical, across the states. So I wouldn't be surprised if the other states would agree to everything that's in there. But if a group from another state were to use AquaQAPP, they should definitely not assume it's pre-approved by their state and run it through review. If you wanted to make changes to AquaQAPP, the easiest way to do that really is to generate a QAPP through the tool and make the changes in the Word document directly, or even develop an SOP. You know, if Rhode Island wanted to use AquaQAPP, you could develop an SOP where it says, you know, instead of this analytical method, replace it with that one, for example. That's the easy way to adapt it to another state. The harder way is to rewrite the code, which is available. It's open source. Anybody can make a copy of AquaQAPP and put it on a new website and have a new version of it. That seems a little unproductive, just given that it's already pre-existing. We have this long wish list of improvements that we've heard over the last couple of years of use. So we would so much rather see the original improved and enhanced rather than start having copies all around. But either way is available to people. So realizing that was a lot, I just wanted to spend a few more minutes and introduce MassWateR. MassWateR is a new tool. We just released it this winter. MassWateR is an R package, and it was developed for fresh and marine discrete surface water quality monitoring data. And it gives groups a streamlined way of screening their data for QC, preparing a QC summary report for MassDEP or for their stakeholders, creating graphics and analyses, and formatting their data for upload to WQX. And WQX is the way, the mechanism for getting data into WQP, the water quality portal. That's a national portal. The beauty of it is there's no R experience necessary. It's beginner friendly, even though R can be very intimidating, and to myself included. And there are additional resources available for MassWateR. We've got a very detailed website and user guide, recorded trainings, and we have a community of practice forum where people can go and find help, ask questions to the community and the developers. So the trickiest part of using MassWateR is getting your data formatted into the proper format, because it's serving such a large array of groups and water quality parameters and locations. We really needed a standardized input format. There are 5 spreadsheets that a user pulls into MassWateR when using it. One is your site metadata. It's a spreadsheet of your sites, and it has to look just like this with all the required fields. A table on data quality objectives for accuracy. So this is something most programs have in their QAPP already. Already looks something like this. A table for data quality objectives for frequency and completeness. So, you know, that's how often you're sampling, doing QC samples like field duplicates and field blanks, and what your target is for completeness. So for example, you want 90% of all the data to be usable. And then a table with some extra information that WQX needs. So things like your sampling method and your analytical methods. Whoops. The 5th spreadsheet, of course, is your water quality results. This is in tabular form. So each row is a record, is a single parameter record for that given sampling day. I can't go too much into detail for sake of time here, but there's lots of training and other materials that I can share on this. So I'm going to jump over to the R console and give a little drive-through view of MassWater. Don't be too overwhelmed by all the coding language. I know it looks like a lot, but the beauty of MassWater is that you can use this free software, R and RStudio, and you just have to open up the script that's already been written. And that's what you see here. This is all script. When you pull it in, there are a couple steps that the user has to do. They have to tell R where to find the data, where those 5 spreadsheets are, and then it assigns those spreadsheets to different values. So it just makes it easier to use them. It gives them easier names. So I'll jump right into a couple examples of what the analysis looks like. I've already done that step of uploading all of those spreadsheets. So we're just jumping in here. So if we wanted to analyze outliers in our data, this would be a QC step, sort of right after a sampling program finishes for the season. Maybe this is the first thing they do is analyze their outliers. So I'll look at this row of code and hit this run button up here. And on the fly, in less than a second, it created a plot of outliers just for DO, because that's what I selected in the code. I told it to look just at the DO records. And I'm looking at all of the outliers across all sites and all of these sampling dates. And it created a box and whisker plot for us, which is a standard analysis protocol, and as well as the outliers. So when I see those 3 outliers, those are 3 sites that didn't fall within the box and whisker for that particular month. And so then I would go and look, if I were the group, I'd go and track down that data record and see what's going on there. Is this something I want to qualify? Do I want to censor that data? Do I want to keep it? So that's part of the sort of iterative QC process that groups are familiar with doing. You could do this, you could change this for every parameter. So if I want to do total phosphorus, I'll just do TP there, run it again. Just like that, a new TP plot comes up with those outliers. So a group could do this one at a time with each parameter, or run this bottom line here that I've highlighted. This creates a Word document that gets saved to your desktop or wherever you point it to, that has all of your outlier plots all in one document. So you can sort of assess them all at once. There's a lot of options in here that I don't have time to go into much, but you can select what dates you want to look at. You can tell it to only look at certain sites. There are a lot of different settings that we don't have time to cover here. Another step in QC review is to look at how your program did against all of those targets, those tables that I was mentioning earlier about your accuracy and your frequency and completeness. So that's what these different functions are used for. I'll just do a couple examples of these. This one is looking at frequency. So it's on the fly, pulling in your data, pulling in that table that you put in there with all of your targets in it, and showing you how your program did with frequency. So if you remember, most of the parameters, the goal was 10% quality control sampling. Well, you can see most of them did all right. Most of them exceeded the target with green color coding. 2 of them for ammonia, we missed the mark for frequency. We only sampled 9% of the sampling was quality control, and did poorly for E. coli. So there's a few different ways of looking at the data there, and I won't go through all of them. But again, just like I was describing earlier, if you want to pull it all together into one report, it's this line of code right here. So this single line of code creates a report, a Word document that gets dropped in your desktop that has all of the performance standards for your program and the analysis of them in one very nicely formatted document. That is what can get sent to MassDEP along with your data, or whatever DEP, state DEP. That's what you can send along to them. So they have your sampling data, they have your QC report, they can look at them together and decide, can I use this group's data in my impairment listing, or whatever use it is they have. MassDEP has already started getting some of these from the users, and they love it, which is great. And they were a big part of helping us, determine the format of that report. So some of the other ones, this is a single line of code that takes all of that input data, rearranges it and puts it in the right format for WQX. So that's to, that'll save an Excel file, again, on your desktop, and then it's ready to go into WQX. So then your data are up there in the federal portal. I won't go through that process because it's more involved, but it's just a single line of code that gets you the file. And then I just wanted to show a couple of cool analysis plots. These are the fun ones to look at, really. Let's see. So this is looking at seasonal analysis, just for TP, total phosphorus. So that line of code pulled up the total phosphorus data. And this is kind of neat because it plugged in a threshold. It used the Gold Book standard for EPA as a 0.05 threshold for total phosphorus, put it right on the plot. You could choose to remove that. You could put a different threshold on there. There's a lot of flexibility around that. You could change the plot type. So this looks a little different. It put the actual data points on there as well, in addition to just the bar plot. So lots of functionality there. And I just wanted to show a couple more. This. Oh, just another example of a different, so this is dissolved oxygen. All of the sampling stations combined for each month of sampling. And you can see they did fairly well here. Most of them are above the standard, the threshold, which in this case is a Mass DEP threshold. So this is showing a Class A, Class B water, warm water threshold. This is one component that's sort of specific to Massachusetts, but like I said, you could remove or change or add a different threshold in there. You could do by site analysis. So then this is breaking down now across the x-axis. These are the individual monitoring locations. So this helps programs look at the variability in their data across sites. Again, we're looking at DO here. The threshold is at 5 milligrams per liter. So all of the sites did quite well in this particular monitoring year. And then the last thing I'll show you here is the mapping function, which just takes a second to process because it's pulling some things off the internet. But with this single line of code, you know, with where it specifies DO for dissolved oxygen, it creates this map of your mean DO values for each of the monitoring sites for that year. That's the mean across the entire sampling period, with a color code for how it did in terms of DO. And there's just tons of flexibility here that I don't have time to describe. You can change this map in infinite ways. You can look at certain times. You can look at wet and dry weather if that was part of your data in your data import. So just tons of customization within this. It's covered in our trainings. So that was the whirlwind tour of MassWateR. And can MassWateR be used in other states? Yes, it definitely can. It already is being used by a couple of interested programs in New Hampshire and in Connecticut. Although it was developed with significant input from Massachusetts watershed organizations, they really guided the parameters and what these the graphics look like. And the QC report really meets Mass DEP's needs. It is also just an excellent output and a great, it's really a best practice for groups to document their QC in that way, just so any end user could use their data, not just a DEP. So if you wanted to use this in your state, you should get feedback from your local users, see if, the watershed groups and others would be interested and what else they would need from it. And also the end users, the DEPs or EPA or others who might want access to the data. And if you wanted to make changes, the R script is very flexible with some R knowledge. You could write in whatever other functionality you want to build in. You don't necessarily have to rewrite it for everyone. You could just rewrite it for yourself. But if there was a desire to recreate the package elsewhere, it's also open source. So that could be done. Again, we have a living wish list of improvements we'd like to see with the next versioning. And we're open to more improvements and suggestions via that COP forum that I mentioned. And I think that's it. Realizing that that was a lot. I'm sharing some links here. I can email them out as well so folks can click around and stuff. But I'm happy to answer any questions or start a discussion about these are